My name is LBarnes. I'm a junior studying computer engineering. I'm attending ECE 311 and 331. I am not taking ECE 451, so I will not be elaborating on the electromagnetics perspective. I will be talking about the AC to DC converter, also known as the full wave rectifier. The full wave rectifier is an important circuit as it powers most every device. I will explain how a full rectifier works from the perspective of electronic principles and the perspective of linear systems. To begin, we will talk about the electronic principles perspective. Our full wave rectifier contains diodes, which are nonlinear elements. Diodes only allow current to flow in one direction. This is particularly useful when we want to take the absolute value of an input. Our rectifier, which is composed of 4 diodes, forces current to only flow in one direction across the output. When our AC source is negative, the current takes one path, and when our AC source is positive, our current takes another path. Both of these paths have positive current across the output of the bridge, effectively taking the absolute value of our voltage input. In this process, we lose voltage from the threshold voltage across the diodes. The path our current takes crosses 2 diodes, so our voltage outputted by the rectifier will be our input minus twice our voltage threshold. Our voltage outputted by the rectifier will be the input to our RC circuit. When the capacitor in our second subsystem does is store charge and voltage across Vout so that our Vout never reaches a low voltage. A ripple signal will be produced, and it is our goal to get the ripple as close to flat line as possible. As we increase the time constant tau in our RC circuit, we can try to get our ripple voltage to decrease to an acceptable level. At this point, we have taken an oscillating voltage source as an input and produced a constant voltage as an output. For a 311 perspective, we will begin by trying to find what Vout is of our system. When we have a linear time-invariant system, we are able to find Vout by taking the convolution of the input signal and the impulse response of the system. Our system is time-invariant, meaning if it has a periodic output, we have a periodic input. Our system is not a linear system because it contains the rectifier, a nonlinear subsystem. The system does not pass the homogeneous test and additivity test. We are unable to take the convolution of the voltage input and the impulse response of our system to find Vout. In order to take advantage of the convolution sum, we must instead use the RC circuit as our linear system. We will use the voltage of the rectifier for our input to find the Vout equation. To find the impulse response of our LTI system, we cannot manually apply an impulse function to our system and find the impulse response. The impulse function is an input that is infinitely thin and infinitely tall, so we must find some other way. What we can do is apply a unit step function as our voltage rectifier and find the unit step response. Because our system is a LTI system, we can simply take the derivative of the unit step response and get our impulse response of the RC circuit. After we have found the impulse response, we can take the convolution of the impulse response with our Vrec that we have found from Vn and find Vout. I'm not in ECE 451, but I recognize why the electromagnetics perspective is important. While 311 and 331 look at a circuit from a high level, 341 looks at each component in a circuit and discusses the physics that make them work. For example, what I have learned from Professor Notaros during the KI is how to make the voltage threshold of a diode, or how to find it. First, we take the integral of the charge across the depletion region to get the electric field. Then we take the integral of the electric field to get a voltage. The amplitude of this voltage across this distance is the voltage threshold of the diode, which we can then use to analyze the full wave rectifier. When we consider our power management system, the full wave rectifier, it is important to view it from each of the 3 perspectives offered in each course. Doing so allows us further understanding of the circuit and helps us develop intuition of how AC is converted into DC voltage. Thank you.